let me talk to you about hydrogen fueled vehicles. Okay. And as you know, hydrogen is known as freedom fuel, or it is one of the most environment friendly fuel. It is the ultimate fuel, okay? Because when the hydrogen burns, the only pollutant that it causes is water vapor, okay? And water vapor will bring you rains, so it is no problem. In fact, you know, hydrogen is one of the ultimate sources of energy. If you look at International Space Station, they carry only hydrogen and oxygen and not water, and that hydrogen and oxygen goes to the fuel cells where the electricity is generated. That electricity is used for running your scientific instruments, and the exhaust, which is water vapor, is used for drinking by the astronauts. So, it is so pure. Okay. Of course, you have to add some salts into it, because pure water you cannot drink. Okay. So, similarly, now people are dreaming of having these hydrogen cars. Hydrogen car is not really a dream. I mean, there are several commercially available cars now. There are several companies which sell hydrogen cars in the market. I will tell you in this lecture, I will tell you about hydrogen fueled IC engine cars as well as hydrogen fueled fuel cell cars. So, both things we will discuss in this course. So, before I start, I would just like to give you some historical perspective as well as some artistic rendition. So, if you look at this is an artistic view of transportation in hydrogen age. Hydrogen economy is a very fancy subject, and it was talked for a very long time. Of course, now people seem to be losing some faith in hydrogen economy, and some people even say that hydrogen economy will never come. Nevertheless, from the academic interest, we should try to study this. So, in the hydrogen age, it is envisioned that, you know, even the large cities will be operating on hydrogen. The ocean transport will be focused on hydrogen. All the city infrastructure, including transportation, industries, residential areas, resorts, everything will be running on hydrogen. So, once you have such a situation, such a civilization where all the activities are based on hydrogen, obviously it will be a pollution free society, because the only pollutant you will be producing will be water vapor. Okay. So, in this basically I will be talking to you, I will introduce you to hydrogen and some historical perspective. I will talk to you about fuel cells and the automotive applications and the kind of cars that are commercial, that are prototypes are developed for hydrogen fuel cell cars, and some of the modern commercially available cars also on hydrogen fuel cells. Then I will talk to you about hydrogen IC engines and the performance of the hydrogen IC engines. Okay. So, there was a famous philosopher by the name Jules Verne. He said that, he made this statement I think about 200 years ago. He said, I believe that the water will one day be employed as fuel, that hydrogen and oxygen which constitute it, used singly or together, will furnish an inexhaustible source of heat and light of the intensity which coal is not capable. Please remember, I am talking about 200 years back. At that time petroleum was not discovered yet. It was the coal on which the entire economy was working. So, he said that water will be the coal of the future. Okay. And there is a lot of water in oceans. Hydrogen is the most plentiful element on the universe. So, hydrogen, we will never run out of energy. That was the dream. And it was, remember, it looks, we are in a technology era where it looks very close to the reality, or at least we can make some steps to make it a reality. But imagine this guy imagined this 200 years back, when even petroleum was not discovered, there were no automotive vehicles, nothing. Technology was in its primitive stage, and what possibly he meant was that you have this sunlight, using this sunlight you do hydrolysis reactions, split the water into hydrogen and oxygen, store the hydrogen, and then use this hydrogen. Of course, in those days there were no cars, but you can use the hydrogen for any purpose that you want, for propelling the ships, for doing any daily course, etc. Potentially, you know, it is an inexhaustible supply of energy can be produced, because there are many primary energy sources of hydrogen production. basically you can produce it from coal, from renewable sources. And if you look at the relative distance traveled by the vehicle types per kilowatt of electricity consumed, this is on kilometers. So, if you look at the hydrogen IC engine car using liquefied hydrogen, this is the distance that it will travel per kilowatt of energy. Hydrogen IC engine car in compressed form, hydrogen fuel cell car in liquefied hydrogen, hydrogen fuel cell car in compressed hydrogen form, and electric car. So, this is the situation with the distance travelled per kilometer. Just to introduce you with the hydrogen, its symbol is H, it is the lightest element, approximately 14.4 times lighter than air. It is the most abundant element in the universe, present in all organic compounds, is colorless, odorless, non-poisonous gas. So, all good here. Atomic number is 1, that means it has only 1 proton and 1 electron, highest energy density in relation to its mass. 1 kilogram of hydrogen has energy equivalent of almost 3 kilograms of or 3 liters of gasoline, 2.1 kilograms of hydrogen. So, on a mass basis, this is the most intense energy form. I think more than this energy is stored only in nuclear fuels. Okay. So, this is very intense energy source as far as mass basis is concerned, but the situation is very bad when it comes to volume basis. Imagine a situation where 1 gram mole of hydrogen, 22.4 liters, is going to weigh only 2 grams. Compare that with 1 gram mole of vapors of petrol. Petrol is, you can assume it to be isooctane C8H18. C8H18 is how much? 96 plus 18, 114. 100, this is going to 22.4 liters of water of the vapor of petroleum is going to weigh 14 grams, and 22.4 liters of hydrogen is going to weigh only 2 grams. You can compare the energy density. Okay. So, although it has 3 times higher energy density compared to petrol, but in terms of volume it will have how much? 6 by 6 is to 114, right. So, around 20 times. So, on a volume basis, per unit volume, this will have 20 times less energy than gasoline vapors. So, on a volume basis, it is a disaster, and this is one of the big problems with hydrogen. How do you store? How do you store so much of hydrogen so that you can carry at least few hundred kilometers, just like gasoline cars. Gasoline cars normally have a range of 600 kilometers, 700 kilometers. One time you fill it, you go to 600 kilometers, do not worry about it. If you fill the same, if you have the same capacity of tank using hydrogen, every 30 kilometers you have to fill the tank. Okay? So, you do not want to do that. Sources of hydrogen generation, many sources are there. So, there could be many primary sources of energy. You can generate electricity from sunlight using wind, photovoltaic, biomass, fossil fuels. Finally, you generate electricity, and this electricity can be used for photoconversion, you can use it for electrolysis, you can use it for reforming, and then finally you convert, you split water or hydrocarbons into hydrogen, and then this hydrogen can then be transported using pipelines or through some kind of a transport means, and it can be stored in gas form or liquid form, and then again it can be used for again production of electric utility if you want, again electricity to electricity, commercial and residential applications, transport needs and industrial needs. Okay. So, this is the entire value chain of end to end of hydrogen production and utilization. Hydrogen is the most plentiful element, but it does not occur in the pure form on the earth. I told you that there is a big debate whether hydrogen should really be treated as fuel. Hydrogen is actually not a fuel in my opinion. You cannot drill a hole in the earth and take hydrogen out. The hydrogen is not available in pure form. Either it is combined with oxygen or it is combined with carbon, and you have to spend energy to split hydrogen and oxygen. And you have to actually spend more amount of energy in splitting than what it will give you when it combines, hydrogen and oxygen combines during burning. So, is it really a good idea? Well, we will look at it. Okay. So, nearly all hydrogen production currently is based on the fossil fuels. Hydrogen can also be produced from renewable sources such as biomass, wind or solar. So, this is one way of actually producing hydrogen in a more environment friendly way. What is being said is that you generate electricity somewhere, and if you do not have a demand center, there is no need to actually transport electricity long distance. You can just have water, use that electricity for splitting water, and then whatever hydrogen is produced, it is basically a CO2 free hydrogen that you have produced. You can use it in the transport sector. That makes sense. If you go offshore in the ocean, in the shallow ocean, there is huge amount of wind. You construct towers there and put windmills. Once you put windmills from the ocean, you can't bring cables and bring that electricity home. There itself you put electrolysis units, and so the wind will generate the electricity. That electricity will split the water. Water is available in the ocean. You will make hydrogen, pump it in the tank. You have a storage tank, store the hydrogen in the tank, and then when it is full, you take it onshore and use it. So, there are many concepts that are being developed, and that is where the hydrogen is being looked into quite seriously. Okay. So, hydrogen can also be produced from conventional sources such as natural gas, oil and coal. So, once you use some of these natural sources, conventional sources that are available to you, you can do it by process called steam reforming of the natural gas. I will talk to you more about this in detail. You can do partial oxidation of these natural gas, coal and oil. You can do thermal cracking of the natural gas. You can do coal gasification. Okay. Coal gasification means you have coal plus water. C plus H2O is CO plus H2. So, basically you are converting coal into carbon monoxide plus hydrogen, and you are generating gas, and this gas then you can separate carbon monoxide from hydrogen. So, hydrogen you can use for some purpose, carbon monoxide you can use for another purpose. You can produce the hydrogen from renewable sources such as biomass. You can use the electrolysis process, and the electricity can be from the solar, wind or hydel. In India, possibility exists for hydrogen production sugar mills, from bagasse power plants. Chlor-alkali units also have hydrogen surplus. So, in India we can use actually the sugar mill produce hydrogen and chlor-alkali unit hydrogen also for transport purposes. Okay. This is a very interesting slide. It shows you how the hydrogen can be produced. So, mostly it is hydrogen extracted from water. There are various methods of generating hydrogen. So, you can do electrolysis. Electrolysis means splitting of water into hydrogen and oxygen. So, if you have energy available, you can do high pressure electrolysis, that means splitting of water under high pressure. You can do low pressure electrolysis also. You can do membrane electrolysis, and you can do high temperature electrolysis. So, high temperature electrolysis can be done by energy and also by heat, and all of this is going to produce hydrogen. You can use the Caverner process. Caverner process means, Caverner process is a very interesting process where you have two electrodes, and in between those two electrodes you generate what you call as plasma. Plasma is very high temperature and pressure conditions. You make vacuum, and through that plasma you put methane, and once you put the methane, what it will do is it will convert the methane into carbon plus hydrogen without combustion. So, the carbon will be then formed in very fine nano form, it is called nanocarbon. It is lot of industrial applications, and then hydrogen will be released, and that hydrogen you can use for whatever purpose you want. This is the Caverner process. Okay. So, methane is used and also electricity for generating plasma, and this is Caverner process. If you have natural gas, you can do steam reforming. CH4 plus H2O is equal to CO plus H2. You can balance the equation, that is the steam reforming. If you have coal, I told you coal gasification is possible. Carbon plus H2O is equal to CO plus H2. If you have biomass, you can do biomass gasification. If you have surplus hydrogen, so there can be actually many sources and many ways of producing hydrogen from many primary energy sources. Okay. So, the hydrogen can actually, hydrogen is a versatile fuel, it can be produced from in many ways. Let us look at one of the simplest methods of production of hydrogen. So, you have water available and the water is split by a process called electrolysis, and it can then be split into hydrogen and oxygen. All of you are very well aware, this is studied in class 6th, I guess. Electrical power is required for splitting, and what you do is you put you take water in a vessel, make it conducting by adding some salt to it or maybe some acid to it, and then you put 2 electrodes connected to a battery. And once you connect it to a battery, then you will produce hydrogen on the cathode and oxygen on the anode. Simple reaction takes place, 2H2O is equal to 2H2 plus O2 in the presence of electrical power. This process of production of hydrogen can be accelerated if you apply high pressure or high temperature. Okay. So, that is why one is the simple electrolysis, then there is high pressure electrolysis, and there is high temperature electrolysis. So, if you apply pressure, it becomes high pressure electrolysis. If you apply temperature, it becomes high temperature electrolyted. So, under high pressure and high temperature, water molecules split very easily, and therefore, the energy requirement, electrical energy requirement under high pressure and high temperature are going to be relatively lower compared to normal electrolysis, and that is why it makes more sense to go for high pressure and high temperature electrolysis. Okay. The advantages of this is that you are producing very pure hydrogen, because it is just water and there is no other side reaction, and it could be powered from cool renewables. When you say cool renewables, that means the renewable sources which do not involve very high temperature for energy production. For example, wind energy is a cool renewable, never the temperature is increased. Solar energy is also a cool renewable until unless you are concentrating the solar to a very high temperature. Okay. So, these are cool renewables, whereas biomass, if the burning takes place, it is not a cool renewable, you are generating heat and then you are raising steam and then you are running a turbine. So, that is not a cool renewable. So, that is the difference. So, when you have cool renewables, obviously it is a low temperature process, and cool renewables you are not producing even the oxides of nitrogen. One of the problems with hot renewables is that somewhere you are producing oxides of nitrogen if you are in a very high temperature regime. Hydrogen thus produced will be abundant because there are oceans full of water, there is abundant supply of water, and the best part of this whole thing is that there is absolutely no moving part. So, since there is no moving part, there is no maintenance, no servicing required. The only thing that you have to worry about is maintaining the level of water and its conductivity and high temperature and pressure in the electrolysis chamber. Okay. But the disadvantage of this is that it is not cost competitive, it is not even energy competitive that way. Fossil fuel powered electrolysis is mostly used in the world right now, okay, and which is not really CO2 free, because the CO2 is not produced when you are generating hydrogen, but it is produced when you are generating the electricity itself in the power plant. Okay. And then the worst part is that the amount of energy needed to divide water into hydrogen and oxygen is equal to the amount given off when the hydrogen burns and recombines with the oxygen, gives you water. This may be even less. So, what it means is that in terms of energy, you are providing some amount of energy, splitting hydrogen, then it again recombines, gives you the same amount of energy or maybe less. Okay. So, essentially then hydrogen, if we say that hydrogen is a fuel, that really is not true, because now here hydrogen is mostly acting as carrier of energy. You are putting one form of energy here, splitting into hydrogen and oxygen, and then same amount of energy or less is produced inside the engine combustion chamber when you recombine it. Okay. So, this is one of the big problems with hydrogen. Electrodes in conductive water produce hydrogen at cathode and oxygen at anode. This is the water, and you have to make it conducting by putting some polar material such as H2SO4, HCl, or maybe some other acid, and then you connect the electrodes through battery, and then hydrogen and oxygen generation takes place by splitting water. Very simple reactions. Okay. So, nowadays you see this solar powered electrolysis is very popular. So, Honda is doing in a place called Torrance in California, and this is a project called High Solar, and they started making hydrogen using solar energy in 1994. And there is another place, Wassernhof Bayern in Bavaria, where the solar energy is used for producing hydrogen. There is one project by the name CAN project, which is also doing the same thing, and here the idea is very simple, that you have a solar photovoltaic panel that generates electricity by capturing the solar energy, and rather than storing the electrical energy in the batteries, you are directly bringing it to the electrolyzer, and there hydrogen and oxygen generation is taking place. So, essentially you are converting solar energy into production of hydrogen without any. This is also maintenance free technology, this is also maintenance free technology. Okay. So, this is very popular route that is being developed further. So, here this shows regenerative fuel cell system. So, here also you see you have solar PV collector, and from here the electricity is generated, that goes to electrical uses for some applications, that also goes to the electrolyzer like this, where hydrogen and oxygen is generated, and then this hydrogen and oxygen basically goes into the fuel cell, where also again whenever sun is not available, when the sun is available you can use this. When the sun is not available, this hydrogen and oxygen can go to the fuel cell, and fuel cell will produce the electricity, and then you can run your appliances, and the water that will be produced will be go back to the electrolyzer. So, this way the availability of the solar energy for running your home appliances round the clock can really be ensured, because one of the major problems with the solar energy is that solar energy is useful only when the sun is there. Solar energy appliance, you have to have another set of appliances which will give you support when solar energy is not there. So, this kind of a system is a whole system where solar energy can actually be stored in the form of hydrogen and oxygen, and that can be used through the fuel cell to generate electricity during the night time. Okay. Then nuclear powered electrolysis is also something that is very it has very high prospects, especially for the country like ours, India, where we are really focusing on large scale nuclear energy production. So, what is done is it is a feasible alternative, because in nuclear energy, when the nuclear fission reactions take place, very high temperature and pressure is generated. Okay. But the problem is that anti-nuclear sentiments exist, and whenever we try to promote nuclear energy, after 10-15 years there is one accident that puts everything back. Recently we had Fukushima, before that we have Chernobyl, and before that we had 3 Mile Island accident. So, these accidents actually again force the planners to think that really should we go nuclear or should we not, but anyway, once we settle that debate, we can go for this nuclear generated hydrogen, nuclear power generated hydrogen. NRDC also opposes, and there is a problem of the spent fuel. So, these are some of the issues with nuclear energy in general. So, basically if you have a nuclear power plant, in the nuclear power plant you generate heat and you generate power. If you generate electrical power, you can do direct water electrolysis. If you have heat, you can have thermochemical cycles to generate hydrogen. You can have, if you have heat and power both, high temperature cycles, and then hybrid thermochemical cycles, and through all these processes you can generate hydrogen and oxygen. Okay. So, this is one very nice way of producing hydrogen. In fact, if India has to go for hydrogen economy, this is one of the most feasible ways to produce hydrogen. One big nuclear power plant can support maybe few cities of the size of Bombay, okay, for transport sector. So, and all the emissions will be gone from the road, but it is a big plan. It needs a big strong willpower to execute, and there will be a lot of teething issues. It is technically also quite challenging. Okay. The other option that we discussed was to produce hydrogen from natural gas. So, hydrogen from natural gas is called basically a process reforming. Okay. So, basically in the reforming you strip the natural gas with hydrogen, and when you do the reforming actually you are converting the carbon into carbon dioxide. So, this is one of the flip side, that when you are doing H2 production by process of reforming, you are actually generating carbon dioxide. So, what is thought is that maybe rather than carrying hydrogen through the pipeline, most of the gas stations will have natural gas pipeline coming to them, and then what you can do is you can have onboard reformer on the gas station. That means you are converting the natural gas that is available to you at the gas station, which is coming via pipeline. You convert it into hydrogen on the gas station itself, and then that can be used for filling in the vehicles. Okay. So, this basically you have to outfit the gas station with a machine to reform the natural gas, and it is not very expensive. It is about, the reformer cost is about 1/4 of the cost of setting up a new gas station. So, this is a really feasible technology if natural gas pipeline is coming to that particular gas station. Okay. Another process that I talked to you about was Cavendish process. It is a very important process. What you do is you take light hydrocarbons, it could be methane, it could be ethane, it could be any other hydrocarbon gas, it could be even liquid fuels such as petrol, and then you use electrical power. So, what I told you was that you generate plasma between two electrodes, and when you generate plasma, plasma is highly ionized gas. Okay. It is totally ions at very high temperature, fourth state of matter. The temperature of the plasma could be several thousand degrees centigrade. Okay. So, in the plasma arc you are actually putting in hydrogen, this many of these lighter hydrocarbons or say methane gas, and you make sure that there is no oxygen. Okay, because you do not want hydrogen to combine with oxygen and also carbon to combine with oxygen. So, you basically try to make oxygen free atmosphere, and in that when you put the hydrocarbon, what happens is that splitting of the carbon with hydrogen takes place. So, the hydrogen gas separates and carbon in solid forms comes out, and this carbon is actually in the form of nanoparticle. This is called carbon black. Okay, and carbon black, there is a lot of industrial demand. Okay, and there is no emission of any carbon dioxide or anything. It has nearly 100% efficient process. So, this is very important process for hydrogen production. In fact, this process is used for production of carbon black. Hydrogen is just a byproduct. Why don't use it? Or maybe you can now make hydrogen as the main product if you want. This is a good process. Okay. Then you see, you do steam reforming. Now, steam reforming also you can do the same thing for the light hydrocarbons. This is endothermic catalytic conversion of lighter hydrocarbons. So, basically lighter hydrocarbons such as methane, you react it with water, steam at around 900-850 degree centigrade temperature, a very low pressure of 2.5 bar. So, it gets converted to carbon monoxide plus hydrogen. Okay. And then this carbon monoxide and hydrogen again under the same conditions reacts, give you carbon dioxide plus water, and the second reaction is called shift reaction. I think you must have studied this in your maybe class 9 or 10. Okay, shift reaction. So, the first reaction is both of these together are called steam reforming of methane for conversion of methane into carbon dioxide and hydrogen. Okay, the CO2 can be then filtered by adsorption or by membrane separation, and if you want to employ such a scheme, very large volumes productions are possible, up to 100,000 meter cube per hour kind of production is possible. Such units can be actually installed, and that will be quite big unit for the production of large scale of gas, large scale production of gas. Okay. Coal, there are a lot of coal. So, you can also produce hydrogen from the coal. This is just a artistic rendition of where the coal are. Say for example, these are the coal veins in the earth crust. So, some coal can be taken out in a feasible manner, some coal is so deep that it is not possible to take it out. So, then what you do is you do underground coal gasification. So, that means you make hole, you provide the air, but not sufficient air. So, when you do not provide sufficient air and you lit the fire in the earth itself, so put a fire, give the oxygen, but not enough oxygen. So, then what will happen? Coal will burn and you also provide steam. So, C plus H2 is CO plus H2, carbon monoxide and hydrogen is produced, and the carbon will actually come out in the gaseous form, and gases you can extract from whatever depth you want. This is called underground coal gasification, because now the coal has gasified, it has got converted from solid phase into gas phase, and then you bring it out and then you can use it for many applications. And nevertheless, you can bring the coal through lot of barges, etc. You can generate electricity, and then this electricity you can also run fuel cells, you can generate hydrogen, hydrogen you can use for generating fuel cells, and many things can be done. In transport sector can be done, factories can be run on hydrogen, dwellings, human settlements can be powered by electrolysis. So, this is just an artistic rendition of basically hydrogen economy visualization. So, coal fired utilities can power the electrolysis because they generate electricity, and electricity can be used for high temperature and high pressure electrolysis. Okay. So, here is the one gasification process. So, basically what you do is you take finely grounded coal powder, you mix it with water, C plus 2 H2O, you make a suspension with 50 to 70% of the solid matter, and then under appropriate conditions you produce carbon dioxide plus water, sorry, carbon dioxide plus hydrogen, and then hydrogen you can remove. This is very profitable in typical coal mining countries such as China and South Africa. Hydrogen is being produced by this method in many countries. Also in India there is a lot of scope for this. Second is, second type of gasification is that in the first step you do pyrolysis, in the second step you do hydrogenation, hydrogen generation. So, in the pyrolysis you can take basically biomass such as plant, wood, municipal solid waste, cultivated energy, and then you thermally decompose it or change into coke, and then you produce condensates and gases, and you will be producing all kinds of gases. This can have carbon monoxide, it can have different types of hydrocarbons, and all different gases you can just put as CX H2X plus 2. It can be double bond, single bond, all you produce very dirty mixture of gases. So, all that dirty mixture of gases, what you do is you take that and you do hydrogen generation through this process. So, then you react it, all these carbon monoxide with water and steam basically, and all this hydrocarbon that you are producing, you also react it with the steam, and then you produce carbon dioxide plus hydrogen. Okay. So, this is also one step which is very, very important for us, because in India our cities are littered with municipal solid waste. We can collect all that municipal solid waste and undertake this pyrolysis reaction to gasify it, and it will produce some hydrocarbon gases, and then you do hydrogen generation using it, and you produce carbon dioxide plus you use hydrogen. This hydrogen can then be used for transport sector, for running your utilities, for your fuel cells, for whatever applications. So, this is another way of gasification of municipal solid waste. Okay, so then people thought that can we think about something out of the box. So, one important discovery which was one of the most significant discoveries of the last decade was that they developed a bacteria. Okay, this is a little bit of a tongue twister, I will still try. Clamoidomonas rindarti, it is tongue twister. Okay. So, basically this is a bacteria which makes hydrogen when you do not provide it sulfur, and this is one of the top 10 discoveries in the 2000 declared by science. So, this is an anaerobic bacteria that produces hydrogen 20 times their volume per minute. So, if you have bacteria, you do not give it sulfur, it will become angry and start producing hydrogen, okay, and 20 times per minute. So, maybe it's just, it looks like a fiction, but maybe you can have a bacteria full of 2 liters or 5 liters in your car, connect it to your engine and trouble the bacteria a little bit, and then you can run your car on hydrogen. Well, it is a fiction right now, but maybe who knows, it may be a reality. Okay. Let us look at the hydrogen. So, we have discussed that hydrogen is highly energy dense material. 1 kilogram of hydrogen is energy is 2.8 kilograms of gasoline, but when it comes to volume, it's terrible. So, question is that suppose you want to use hydrogen as a fuel for transport applications, how are you going to store it? So, hydrogen storage becomes extremely challenging, and in fact, this is one of the major bottlenecks why hydrogen cars are not so popular worldwide. It is not that technology does not exist, but the technology, efficient technology for storage does not exist right now. So, there are 3 or 4 different ways of storing hydrogen. One is that we have seen that we store methane under pressure. Methane we stored in 2 ways, compressed natural gas and liquefied natural gas. Both ways are applicable for hydrogen also. We can store the hydrogen in compressed form. The only difference is that here the pressures will be 350 bar to 700 bar. Okay, this is a little old technology, so old numbers, but now people are talking about storing hydrogen from 300 bar to 700 bar, first thing. If it comes to liquefaction, methane liquefied at minus 162 degrees centigrade. Hydrogen is close to minus 200. So, you have to even go further down in order to liquefy it. Okay. Well, actually it is even more, 20 degree Kelvin. So, minus 250 degree C. So, you have to actually cool it to very, very low temperatures, and then you can liquefy it. Third is that you can store in metal hydrides. Okay. Metal hydrides I will discuss in detail. Metal hydrides are like sponges. So, they have lot of pores and hydrogen can go and nicely sit there, and when you need, you heat it, it will come out. Okay. And then the next thing that is being developed is carbon nanospheres and carbon nanotubes, CNT storage for hydrogen. CNT, as you know, have very large surface area per unit mass, because this is nano. Okay. So, at nanoscales, carbon will adsorb hydrogen. Adsorption is a surface phenomena, and for nanomaterials, you have very large surface area compared to micro or micro materials, I mean which are in micron size. Nano size, the surface area per unit mass is extremely high, and that property you can use for storage of hydrogen, and this is still under development. So, this is something that is still being developed, and this is thought to be one of the game changer technologies if we are able to develop it successfully. Now, what is the problem with these 3? Let me tell you what are the problems with these 3. Suppose you start with 100 megajoule equivalent hydrogen. Okay, you have at 1 bar 100 megajoule equivalent energy hydrogen available. Now, you want to compress it to 350 bar or say 400 bar. So, now where the compression energy is coming from? Obviously, you say that okay, from this 100 megajoule take whatever energy is required for the compressor, I will give it. So, now once you give it at 350 bar, only 70 megajoules will be available to you. So, that means 30% of the energy is consumed in compression itself. So, you are paying for 100, getting 70, 30% energy gone in compression. Okay. If you go for liquefaction, you start with 100 megajoule, you get 60. 40% energy is gone in liquefaction, because cryogenic technology is highly inefficient technology. It has to go down to 20 degree Kelvin, lot of energy is required, and 40% energy gone. Storage in metal hydrides, 30% energy gone. So, one of the big challenges that remains is that you do not want to lose substantial amount of energy in storage, and this is just storage, you are not using, it is a waste. So, can we develop something where we do not have to spend that much energy for storage? You see, you can't see this, but it's there is a bus here, and this is the bus rooftop, and what you see here is 1, 2, 3, 4, these are hydrogen cylinders, and you can see that it does not look like metallic. So, they have to be absolutely carbon fibers, very high strength carbon fiber materials, because the gas is stored under pressures as high as 700 bar. And it is important for mobile usage where light and small tanks are required. Okay, you in mobile applications you can't have bulky material. You have seen initially I showed you CNG, big balloons. Those things are not possible today. We don't have so much of space. So it has to be small, and then at the same time you want large range. So you have to put in more amount of hydrogen in it. In order to have more amount of hydrogen packaged in small volume, the only thing you can do is increase the pressure. So the pressures have now gone as high as 700 bar, and mind you, this is a rooftop of a bus. In the bus normally you have much higher space compared to what you have in a car. Okay, so even for a car, so for mobile applications light and small tanks are required. The material that is used is carbon fiber composite material with internal aluminum liner. Why the internal aluminum liner? Because hydrogen is a small molecule, it can penetrate. So you put a aluminum liner inside, it does not provide any strength, but it prevents the hydrogen from leaking into the atmosphere. You do not want hydrogen to leak through it, right. So this is the story with the pressurized tanks. If you want to go for cryogenic tanks, okay, store it as liquid, again here pressurization is not required because it is atmospheric pressure, but the temperature has to be very low. You have to liquefy at minus 255 degrees C. So waste steam losses are very low, high storage density, perfect for car with less available space. So in fact, if you look at the BMW hydrogen cars that are sold commercially, now they are based on liquid hydrogen. Okay, so you just like gasoline, you can fill liquid hydrogen from gas stations into it, but the big disadvantage is that high amount of energy is required for liquefaction. Okay. Third thing is that you can actually, what you see here is a metal hydride. Okay. So metal hydride storage works like a sponge saturated with water. Suppose I have a glass of water, I put it here and I spill it. So if I spill it, then I have to put, if I put a sponge, that sponge will suck that water inside it. Okay. And if I have to, and the sponge will get saturated. And then when I need the water, what I will do? I will squeeze the sponge, and when I squeeze the sponge, the water will come out. Exactly in the same way the metal hydride storage works. So here sponge is metal alloy and water is synonymous to hydrogen. Okay. And the best part is that it has no losses and it cleans the hydrogen energy. It is very safe in the sense, if you have a tank which is having metal hydride and you are going in a car and a huge truck comes and bangs you from the back such that पीछे की कार के चिथड़े उड़ जाते हैं, but the tank, suppose tank also get burst, what will happen? Nothing will happen. Why? Because the hydrogen is locked inside, it will not catch fire. So that way, from transport point of view, you have to look at the safety aspects also, and this will be extremely safe. And the way it works is that suppose you have pure hydrogen and you want to fill it in the metal hydride, in the metal actually, which is spongy metal. So when you fill it, it's an exothermic process. That means the heat will be generated. So when the gas is being filled, you have to actually remove the heat. Okay. So when you remove the heat, more and more will gas will keep on filling, and at one point in time it will get saturated, and then when you need, what you need to do is you heat the sponge, and when you heat the sponge, release of the gas is endothermic. So endothermic means you have to supply the heat. Okay. And once you supply the heat, the hydrogen will start coming out and that will go into your engine. Okay. So even if the tank is damaged, the hydrogen stays bonded inside the matrix, and this is hydrogen adsorption process. Okay. And the disadvantage of this is that hydrogen has to be filled in the metal. Metal is heavy, so the tank is quite heavy, and of course metals that have this adsorption capacity are also very expensive. So this also turns out to be very expensive. Okay. Now how do you use it? I will come back to this hydrogen storage once again in more detail later on, But let us look at briefly about the usage. So, if you want to use it, two usages are there. One is that you can go for fuel cell or you can go for engine. So, when you go for engine, you normally go for bivalent engine, that means one engine which can operate on gasoline as well as on hydrogen. Okay. If you go for fuel cell, you can have monovalent fuel cell, that means you just have one motor and that is about it. So, fuel cell powers the motor. So, it is a fuel cell powered electrical car, right. Or you can go for hybrid, that means there is a fuel cell and then there is a engine, and fuel cell is powered by hydrogen and engine is powered by conventional fuel. It could also be hydrogen powered engine. So, that is also a possibility. So, this is the hybrid technology.